Hello everyone. Today we are going to study about the discovery of electron. As we know that electron was discovered by J.J. Thomson by studying electrical discharge through the gases partially evacuated glass tube which is also known as cathode ray tube. I am showing you the construction and working of cathode ray tube. Just give your attention. Let's see the construction of the cathode ray tube. In its construction, we have to take a glass tube with the closed end. This one is a closed-ended glass tube. At both the ends, we kept two metal plates. This metal plate is connected to the external battery. This glass tube is connected to the vacuum pump this way. Once again, a glass tube with the closed end. At the both the end, we kept two metal plates which are connected to the battery. The battery have a two terminal, as we know that one is positive, another one is negative. In 10th standard that you study, the smaller part, that means this one, is a negative terminal, considered as negative terminal, and this one is considered as a positive terminal. The metal plate connected to the negative terminal is referred as cathode. The metal plate connected to the positive terminal of the battery is known as anode. Vacuum pump is used to create a low pressure inside the tube. The tube is filled with any gas like hydrogen, oxygen, nitrogen, etc. etc. Okay. Once again, see the construction of the cathode ray tube. We took a glass tube with the closed end. Both the end we kept the two metal plates, and these metal plates are connected to the battery. The same thing we wrote in our description. A closed-ended hard glass tube is fitted with the two metallic plates at the ends. A high voltage battery is connected to the metal plate. These metal plates are known as electrodes. Then the metal plate connected to the negative terminal of battery is known as cathode, and a metal plate connected to the positive terminal of battery is known as anode. A metal plate connected to the positive terminal of battery is known as an anode. A metal plate connected to the negative terminal of battery is known as a cathode. This glass tube is connected to the vacuum pump, which create a low pressure inside the tube, which is filled with the gas. You can take any gas like hydrogen, oxygen, nitrogen, etc. etc. A glass tube is connected to the vacuum pump to create a low pressure inside the tube, which is filled with the gas. Clear? So this is the construction. The first question arises in our mind, why it is required to connect to vacuum pump. Then when we see the working, then you realize these things. In its working, at normal pressure, that means a regular pressure 1 atmospheric, when we pass the high voltage current through this battery to the discharge tube, then gases does not shows the conduction of electricity. Clear? Okay. So we have to create a low pressure. When the pressure is very low, around about 10 raised to minus 4 to 10 raised to minus 6 Pascal, and around 10,000 volt to 20,000 volt voltage current is passing through this, then the some unknown rays is emitted from the cathode to the anode. How it come to know that the rays are emitted from the cathode to anode? Then during the construction of this cathode ray tube, we make a tiny hole in an anode, or we will take a perforated anode. Just give your attention here. This anode is perforated, and beside this, that means this wall of the cathode ray tube is coated with phosphorant screen like zinc sulfide. You can say that this is a fluorescent screen also, or phosphorant screen also. When any unknown rays will strike on this, it glow. So we came to know that the some rays that should be emitted from the cathode and striking on the anode. Okay. So in a construction of this cathode ray tube, we have to mention this anode is a perforated. I am mentioning here the wall of the glass tube. Behind the perforated anode is coated with phosphorant screen like ZNS, zinc sulfide. Now let's see the working. The high voltage current is passing through the discharge tube. The gas filled in a discharge tube does not conduct the electricity, but at very low pressure, approximate 10 raised to minus 4 to 10 raised to minus 6 Pascal, and high voltage current approximate 10,000 volt to 20,000 volt, once again, and at atmospheric pressure, the high voltage current is passing through the discharge tube. The gas filled in a discharge tube does not conduct the electricity, but at very low pressure, approximate 10 raised to minus 4 to 10 raised to minus 6 Pascal, and high voltage current around 10,000 volt to 20,000 volt is applied across this metal plate. Then the some unknown rays is emitted from the cathode to the anode. These are the rays. These rays are strike on the fluorescent screen and they glow. So we come to know that these rays are emitted from cathode. This rays is known as cathode ray. These unknown rays are known as cathode ray. Once again, at atmospheric pressure, the high voltage current is passing through the CRT tube. It does not conduct the electricity, but at very low pressure, that is created by the vacuum pump, around about 10 raised to minus 4 Pascal to 10 raised to minus 6 Pascal, and the high voltage applied across this metallic plate, then some unknown rays is emitted from the cathode to the anode. These rays striking on the fluorescent screen and it shows the glow. That means these rays is emitted from the cathode only. Clear? These rays are known as cathode rays. Okay? Once again, at atmospheric pressure, when we pass the high voltage current through the discharge tube, it does not conduct the electricity, but at the very low pressure, the high voltage current is passing through this discharge tube. Then some unknown rays are emitted from the cathode and striking on the fluorescent screen, and the fluorescent screen shows the glow. These unknown rays are known as cathode rays. Clear? Once again, let's see the working of this cathode ray tube. At atmospheric condition, when we apply the high voltage current to the cathode ray tube, then the gas filled in a cathode ray tube does not show the conductivity, but at very low pressure, around about 10 raised to minus 4 Pascal to 10 raised to minus 6 Pascal, and high voltage current, that is around about 10,000 volt to 20,000 volt current, is applied to the electrode, then the gas filled in a discharge tube shows the conductivity. The current is flow through the stream of the particles, that called the rays, which are emitted from the cathode and striking on the fluorescent screen kept behind the perforated anode. A bright spot is developed on this fluorescent screen, so we come to know that these rays are emitted from the cathode, so they refer as a cathode rays. Clear? Once again, let's revise the whole topic. Construction of the cathode ray tube. In its construction, the cathode ray tube, we took a glass tube with the close end. Both the end we kept the two metal plates. The metal plate connected to the negative terminal of battery is known as cathode, and the metal plate connected to the positive terminal of battery is known as anode. The high voltage battery is connected to both the terminal, which create a current around about 10,000 volt to 20,000 volt. The anode is perforated. Beside this anode, the wall of the glass tube is coated with the fluorescent screen like a zinc sulfide material. A gas is filled in a glass tube, and the glass tube is connected to the vacuum pump. Vacuum pump is used to create a low pressure inside the tube. Clear? This one is the construction of the cathode ray tube. Now see the working. At atmospheric pressure, when we pass the high voltage current through the cathode ray tube, then the gas present inside the glass tube does not conduct the electricity. But when we applied the high voltage current at very low pressure created by the vacuum pump, round about 10 raised to minus 4 Pascal to 10 raised to minus 6 Pascal, then we came to know that some unknown rays are emitted from cathode to perforated anode, which develop a bright spot on a fluorescent screen. So we can say that rays is come from the cathode. These unknown rays are known as cathode rays. Now let's see the properties of this cathode rays. Just give attention. Cathode rays are travel in a straight path. How come to know this thing? When we place a hard object or a solid object in a path of the cathode ray, then it casts a shadow at the opposite side. That means these rays are travel in a straight path. This one is a CRT tube. Cathode and anode. Cathode connected to negative terminal, anode connected to the positive terminal. High voltage current passing through this one. Then cathode rays are emitted from the cathode, and I place the very hard object over here. Then it produces a shadow on the opposite end. So I came to know that this particles is travel in a straight path. This one is the proof. Second, when I place a paddle, then cathode rays set on the paddles, and it converts its own kinetic energy to mechanical energy by rotating these paddles. That means these cathode rays have some mass, and that means they have some tiny particles. Once again, a paddle will place in a path of the cathode ray. The cathode ray strike on the paddle and it rotates the wheel. This shows that the kinetic energy of cathode ray is converted into mechanical energy. So we can say that the cathode ray produces the mechanical effect and it has a mass. I am showing this thing in a diagram. This one is a CRT tube. Negative terminal, positive, negative, positive. Anode and cathode, high voltage current is passing through this. The rays are emitted. I place a wheel in a path of this. This ray will strike on this pedal of this wheel, and it shows the rotation. That means this cathode rays have some particle which has a mass, and they can produce the mechanical effect like this. Number 3. When electrical and magnetic field applied to this cathode ray, they shows the deflection. Just give your attention. In a first case, as usual, this one is the construction of the cathode ray tube. The cathode rays are emitted. Now just give attention. This one is the positive terminal, negative terminal, electric field. Then observation shows that when the rays are passing through this electric field, it shows attraction towards the positive terminal. Clear? What does it mean? This cathode ray have a negative charge because it shows attraction towards the positive terminal. Clear? Same way, when I applied magnetic field to the cathode ray, this is a north pole and this one is a south pole. These rays are bended towards the north pole. That means they are attracted towards the north pole. What does it mean? They have some negative charge particle. Clear? This all properties I show in the very small animation file. Just give your attention in this animation file, so you clear about that particular properties of the cathode ray, and then after we will see the rest of the properties of cathode ray. Okay, just see.
Cathode rays are produced in a discharge tube. A vacuum pump is used to evacuate the discharge tube. The cathode of the tube is connected to the negative terminal of the battery, and the anode of the tube is connected to the positive terminal of the battery. It was observed that, at normal pressure, the gas did not allow the current to pass through it. However, when the pressure of the tube was reduced to 0.001 mm Hg, and a high potential difference between 10 kV and 20 kV was applied, at the end of the tube, a glow was seen on the walls of glass tube. The rays emitted by the cathode travel towards anode. The attraction of rays towards anode reveals that the rays carry negative charge. Properties of cathode rays are: 1. When any object is placed in the path of the cathode rays, these rays cast shadows. This shows that cathode rays travel in straight line. 2. When a wheel was placed in the path of cathode rays, the wheel rotates. This shows that rays consist of some particle and some kinetic energy. 3. In the presence of an electric field, the rays are deflected towards the positive plate. This confirms that cathode rays consist of negatively charged particles. 4. In the presence of a magnetic field, the rays are deflected. This shows that the cathode rays are affected by the magnetic field.
So, you saw that video. In that video, when we place a solid object, then it shows the shadow. That means the cathode ray travel in a straight path. In a second part, the second property, when a paddle wheel is placed in a path of the cathode ray, then the kinetic energy of the cathode ray is converted into mechanical energy and it rotates the paddle. That means the cathode ray has a mass and which has tiny particles. Third, when we apply the electrical field, then the cathode rays are attracted towards the positive plate, which shows that the cathode ray have a negative charge particle. When we applied the magnetic field, then also it shows the attraction towards the north pole, which is also shows that the cathode ray have some negative charge particle. Now we will see the other properties of the cathode ray tube. The fourth property, cathode rays are penetrate the thin layer of matter. The fifth property is they produce fluorescence effect on zinc sulfide. Sixth, when they strike to the hard metal like copper, X-rays are produced. 7. These rays are ionize the gas through which they pass. These rays can produce chemical change and affect the photographic film. Our television screen, our monitors, computer monitors are actually working on the cathode ray, working on the principle of cathode ray tube. The screen is actually coated with the fluorescent material. When the rays are emitted and they strike on this fluorescent screen, they develop the picture. This is the use of the cathode rays. Let's recall all the properties of cathode rays. The first property, cathode rays are travel in a straight path. Second, cathode ray produce the mechanical effect, and on the basis of this experiment also we can say that cathode ray have some particles which has a mass. Third, cathode ray have a negative charge, and also we can say that they are shows the deflection in presence of electrical field and magnetic field. The fourth property of the cathode ray, that is the cathode rays are penetrate the small thin of paper. When the cathode rays are strike on the very hard metal like a copper, they produce the X-rays. Cathode ray, they shows the fluorescence effect when they strike on the zinc sulfide type of the plate. Cathode rays are ionize the gas through which they are passed. Cathode rays can produce the chemical change and affect the photographic film. The television tube, picture tube is actually cathode ray tube, and when the cathode rays are passing through this, they strike on the television screen. Television screen is actually coated with the fluorescent screen and we can see the picture, right? So these are the properties of the cathode rays. In the next topic that we will see the charge to mass ratio of the cathode rays. Cathode ray is never dependent on the nature of the gas and the material of the electrodes.